For part A, combining similar terms, we're going to need to know what a term is. Here's an algebraic expression. 3x is a term, and 5 is a term. Terms are the things in an algebraic expression that are separated by a plus sign. Here's another example of an algebraic expression. You can see the terms. 2x squared is a term. 4x to the 5th power is a term. It looks like 7x should be a term, but in fact, the term is negative 7x. Negative 7x is a term. Negative 8 is a term. In order to be a term, it has to have between it and the next term a plus sign. We don't actually need to change minuses to plus negatives every single time, but we do need to think of them that way mentally. Here's one more. The terms here are 8t, 7, negative 6t, and 4. In this case, I have some terms that are like other terms in this expression. I think the easiest ones to talk about are the 7 and the 4. There's no variable on these terms. They're just 7 and 4. Using the commutative property of addition, I could reverse the order of these two terms. When I do this, I need to be very careful, at least mentally, to think of this as plus negative 6t. In other words, I need to make sure that this minus goes with me when I move the 6t to a new position. So let's rewrite this now with these two terms in their new positions. 8t minus 6t plus 7 plus 4. See, these two terms here have just been reversed, but this minus went with the 6. That's an important feature because when I talk about combining similar terms, or combining like terms, as some textbooks call it, I need to know that I can look at terms that are the same as being next to each other, even when they're not. I don't actually have to do this reordering of these terms in order to be able to say that 8 t's take away 6 t's is 2 t's. Here I've reordered them so that they're together so that I can see 8t minus 6t is 2t. That's just as simple as saying if I have 8 of something and I take 6 away, then I have 2 left. Here what I have 8 of is t's. What I take 6 of away is t's. I'm talking about the same kinds of things here. So I can combine these. When working with constants, I think of the things that I have as ones. So here I have 7 ones in a pile. Here I have 4 ones in another pile. If I put them all together in one big pile, I end up with 11 ones. Now I can't combine these two terms because although I might think of this as a pile of 2 t's and a pile of 11 ones, if I try to combine them into one pile, I'm still going to end up with some t's and some ones. They're different kinds of things. So I can't put them together and say I have 13 t's. I don't. I only have 2. So looking at this problem from scratch, I could just go straight to the things that I knew had the same variables or the same labels. I have 8t, take away 6t is 2t. And I have 7 ones and 4 ones for a total of 11 ones. This is my final answer in this case. Let's take a look at another problem. If I ask you to simplify 4a minus 7b minus 2a plus 3b, hopefully you'd see that what you had were some a's and some more a's, or actually a debt of a's. And in other terms, you have some b's and some other b's. I can put the a's together. I have 4 of them here. And here it looks like I have a debt of 2, or I've spent 2 of my a's, for a total of 2 a's. I start out with a debt of 7 b's. Remember, this is like saying plus negative 7b. Adding negative 7b and positive 3b gives me a total of negative 4b, which I can write this way. But since addition of the opposite is the same as subtraction, I can also write it this way. Let's do one more before we go on to another part. Simplify the following expression. 5x plus 1/2 y minus x minus 3/2 y. I have x's and y's in this expression. It's not written, and so it may not be obvious, but there's an invisible 1 in front of this x. Whenever you see a variable by itself, you can think of it as being one of those. This variable looks like it's by itself, so it's like saying 1x. So what have I got? 5x is in this pile, and I'm going to spend or give away 1x. So by the time I'm finished, I've got 4 x's left. What is it that I'm doing here? I'm adding together, or in this case subtracting, the numbers in front of the variables. I'm combining the 5 with the negative 1 to get 4. That's what I need to do here. To find out how many y's I have, I need to add, or in this case subtract, 1/2 minus 3/2. I didn't write down 5 minus 1 equals 4. I did that arithmetic in my head to get this answer here. But because I'm working with fractions, I may want to write this problem on scratch paper. 1/2 minus 3/2, because I already have a common denominator, is 1 minus 3/2. Simplifying this gives me negative 1. So the number that needs to go in front of the y in my answer is negative 1. Technically, you don't need the 1 in front of a variable. Like I added this 1 here so you could see that it was there. This could also be written as 4x minus y. On an exam, I'll take either of these answers as being correct. Either of those would receive full credit, as long as you show your work. Your textbook takes a slightly different approach to this problem just in the very beginning. First, it uses the commutative property of addition to reorder the terms, just like I did in the previous problem. I didn't do that here. Let's start by changing the order these two terms are in. 5x minus 1x, or minus x, plus 1/2 y minus 3/2 y. Now let's use the distributive property backwards. Notice that if I had started with this and distributed from the right, I would have ended up with x times 5, which is 5x, minus x times 1, which is 1x. And that's what I have up here. So what I've got in this line came from using the distributive property backwards. I can do the same thing with my y's. If I undistribute the y, I get 1/2 minus 3/2. Now it's really clear that 5 minus 1 is 4, and since that's in parentheses, I should do that before multiplying by x. And 1/2 minus 3/2 is negative 2/2, And again, I should do that arithmetic before multiplying by y. Simplifying negative 2 halves, I get minus 1. That's the same answer as I got before. Let me write it without the 1 in front. Again, either of these would be considered acceptable for full credit on an exam. The idea of undistributing is very important, and we're going to be learning how to do that more later on in the quarter. You don't have to do it that way just now, but I think it's a good idea to point out that it can be done, because it's actually going to be an important skill a little later on in the quarter.